Hi, I'm Elizabeth Abraham. You are 14CS139 and I'm here to explain my Unix lab experiment number 3, and it's about looping. So the first question is Fibonacci series. So Fibonacci series is like the sum of the first two numbers should be the third number. We use while loop here. So first I'll ask the user to enter the range till which he needs a Fibonacci series, and we'll read that variable, and the sum is expressions of a plus b. So we will first we will echo that the Fibonacci series range, and we can't use for loop because we don't know definitely how many times it is going to be in loop. So we use the while loop, and we can use the formula while done. So here first I will echo the sum because sum is the third number. Okay, then for a equal to b, a less than a equal to b, so that means b's value is going to be a, and the sum value is going to be in b, and the sum is equal to expression of a plus b, and this is Fibonacci series. So let me run this code. sh fib.sh. So enter the range of the Fibonacci series. So I'll write it as till 13. So the Fibonacci series within 13 ranges 1, 2, 3, 3 plus 5, 3 plus 5. Okay, fine. 1 plus 2 is 2. Sorry, 1 plus 2 is 3. Then 2 plus 3 is 5. 5 plus 8 is 13. Because since I asked within 13, it will show within 13. The next question is to find the sum of the series. Sum of the series is like the series is from 1 square plus 3 square plus 5 square. The odd numbers squares are being summed here. So the program is like, first I have to enter the range, then I am putting it in the for loop, then first I am finding the square, and then I am adding it with the sum. The initial value of sum is 0, so the sum will get the values after each iteration. Since the j it's of odd numbers, first I will initialize j equal to 1, and it will be increment by 2, so it will find the odd number series. So let me run it. WQ. SH. So first I have to enter the range. I'll give it as 4. Now it will take 1 square plus 3 square plus 5 square plus 7 square. So I got the result as 84. The next question is to find the Armstrong number. Armstrong.sh. Okay, here I have to enter the number which I have to check. So Armstrong is like, if it is a 3-digit number, then the cube of each digit will be added, and if it is equal to the number I entered, then it is Armstrong number, else it is not. So again I am putting it in the while loop, and first I am finding the modulus of a number, then I am adding the b. First b is equal to 0, so I will be adding it, so I will get the its unit place times place like that, and I am dividing it by 10. So if after that I'll find it, then I am finding the sum. The sum is like for 3-digit number I'll find the cube root, and again I am finding the modulus, and I am dividing it by 10, and if the number I entered is equal to the sum, it is Armstrong number, else it is not. So let me execute this one. Enter. So number to be checked for, I will check 153, which is already an Armstrong number. I will check for other number. This is Armstrong 121 and it is not an Armstrong number. The next question is to find the palindrome. So vi palindrome.sh. So palindrome is like, if 121 is a palindrome, that means even if you read from the first or from the last, it is going to give the same answer. So for that I have to first take the modulus, then I'm doing it with 10, so I'll get the unit place and I'm adding the value, and after that numbers I'll divide by 10. So if that value after reversing is same as the first value, then it is a palindrome number, else it is not. sh palindrome.sh. I'll give 13431, which is a palindrome, and it shows as a palindrome, and I'll give 1234, and which is not, and it will print as not a palindrome number. The next one is the array question. Array is like I'm entering a few values, and I have to put it as an decrementing and in ascending order. Okay, the first I am asking the size, and after that I am getting the values. So each value will be entered in the array. So this is how the value in an array is taken with the curly braces. After that the array name, and inside the square loop I am again putting the position or the pointer. Then after that first I am sorting it. This program is mainly for sorting, so first I am sorting it, and I am using like I'll compare the first two values, and if it is greater then I'll put in the right side, if it is smaller I'll put in the left side, and similarly I'll calculate the next two values. So this method I am using. So first for the ascending value, the new array in which I have put the sorted value, the for loop will run from 0 to the size of the array, and it will print the ascending order. For the descending one, I am using another for loop from the back, that is from n-1 till 0 I am printing it. So this is the loop part, and I am using two loops over here. So array size I will give it as 9, 18, 5, 21, 66 and 2. Okay, in ascending order I will get it as 259, 18, 21, 66, and in descending order the array will read from the backwards. So another one more question is left out. Find the prime number. Prime.sh. Okay, the prime number is like a number which is divisible by the 1 and the number itself. So here also I am using two loops, one to read from the range, because the user is entering the range from which to which he has to get the prime numbers. So say it is from R1 to R2. So first for loop is running from R1 to R2, and the second for loop will be running till the half of the R2. So if the number is like from 10 to 20, then I have to check the numbers till 50, that is 10 plus 20 divided by 2, 15 I have to check, and if it is none divisible, then I don't have to care about the rest because it won't be divisible. So for the for loop, first for loop will be running from R1 to R2, the second for loop the J, and obviously one will be divisible by all the numbers, so we are not taking the value of J as 1, so we are taking it as 2, and it should go till I divided by 2 as I said, and J plus plus. If the modulus, if it gives a reminder, then it is not a prime number, and if it gives a reminder as 0, so if it gives a reminder as 0, then it is not a prime number. If it gives us some reminder, then it is a prime number. So this is the program. This is prime. message. The range I'll give it from 10 to 30. Okay, so the prime numbers are being printed over here. So that's all about my experiment. Thank you.